Hello everyone, my name is Shelby and I'm going to be presenting my business analytics and data mining final project. So basically we're going to be doing modeling, evaluation, deployment using IMDb scores. This is the website for reference in case you've never seen it. So basically I'm just going to be going into a couple different machine learning models to analyze this particular data set, which has over 5,000 movies, and we're going to evaluate those different models to see which one fits best. Quickly looking over the columns in this data set, you'll notice that there are quite a few objects in this set which will not work for our analysis, so those will have to be dropped. And looking at a correlation heat map, you can see the important factors that have higher correlations not only with each other but also with the IMDb scores. So pointing some of those out, you'll see that the number of users who voted is pretty important against the IMDb score, as well as the duration of the movie. First, I will go into the regression techniques used. There's going to be a couple different algorithms with the IMDb score as the Y value. And then we'll also point out some important features in our models to try and see which predictors are stronger and which need to be included in the model so that it is simplified. Moving into model development, the first model we will do is the lasso model. We're going to try to reduce the complexity and prevent overfitting and try and select our important features. So like I said, all of the objects need to be excluded because we can only use numerical columns in this analysis. Here we are dropping the columns that can no longer be used because they are not numerical. Here are the columns that are produced from our first method. You can see the coefficients are pretty low, but I'm not entirely pleased with this R-square value of 0.341. It's not great. We want it to be close to 1. That's what you look for throughout this analysis. So let's see if the next model does better. Our second model is Ridge. It's going to hopefully shrink the coefficients and help reduce the complexity as well as multi-collinarity. Looks like here our R squared is 0.358, still not very good. Yes, slightly higher, not where we want it to be though. Model number 3 would be feature selection. We would like to select the important variables that contribute the most to our IMDb score. Let's see if we can do that. Okay, it looks like we have 3 different columns selected because I did a K equals 3. So those particular columns are the number of critics for reviews, the duration of the movie, and the number of users that voted. This lines up pretty well with the analysis performed in part 1 of this project, as well as the heat map that we just viewed earlier. And that was the K-best method that we just used. Okay, and this R squared is not very good, sitting at 0.281. That's even lower than our previous, so not the best. Model 4 is our random forest regressor. It is a pretty complex technique, kind of difficult to explain. This is to make sure that you're still listening and you haven't fallen asleep yet. It's a picture I found on the internet. So this is the R squared that we have been looking for, 0.915. That is 3 times better than our first 3 models. And so this is the model that I am choosing to go with. And now we're looking at our feature importance. All of these column rankings or number assignments add up to 1, so you can see the order of which these are valued and their importance. So this is the top 5 features visualized: number of voter users, duration, budget, number of users for reviews, and the gross of the movie. Okay, so yeah, like I said, by far the best model would be random forest. Let's see how it does. So the R squared is 0.5 for when we're actually trying to use this. Since it is our best model, we're going to continue on. And this is the first 2 lines of our predicted values with this model. Like I said, 50% accuracy, not terrible, could be better. Okay, moving into classification. We're going to go ahead and build some classification models and look to see if we can predict if a movie is good or bad. So first we got to create some bins for bad, okay, and good movies. Those are the ranges that we use. And so we're creating a categorical column essentially, and this will allow for our analysis. And this, at the end right here, these are the assigned categories, those buckets that we just created for the first 5 movies. Pretty cool stuff. So here are the 4 models that we're going to take a look at. Real quickly, some important features. We've already established these. Decision tree. Okay, so this is launching it. And we see that it is at 0.67. Could be better, could be worse. The confusion matrix, I will go ahead and interpret. You can see the darker shaded ones are the ones that we predicted properly, or at least along this diagonal here. It looks like we did a pretty good job of predicting the movies that would be good. And I think at about 70%, 75% accuracy predicting the good movies. And overall accuracy of the matrix was 67%, like I mentioned earlier. So not terrible, did a pretty good job for some of the categories that we created. This is a visual of the decision tree. Lots of branches here. Okay, logistic regression model. Looks like it's 0.658, not as high as 0.67, so we will move on. The RFE selection. This is going to assign ranks. The ones with 1 next to it are important, so I will show you what those are. Number of critics, the duration, number of faces in the poster. Thought that was very strange because it's the first we're hearing of this. And the number of user reviews. Let's put this on the model and see how it turns out. Okay, the new variables included, we're sitting at 0.6475. Not as good as 0.67. Still not completely satisfied with these. Okay, what about the extra tree classifier? Here you see similar importance as some of the prior features we've selected, so nothing out of this list really surprises me here. Pretty good. Let's see. Okay, some advanced algorithms real quickly. Gradient boosting. Looks like it's at 0.64. The score is not super important for this actually. Support vector machine. 0.64. Neural network. 0.6448. I mean, come on now. They're almost all the same. Like, they are not as good as the first model that we demonstrated, which was our decision tree model. So, you know, it's kind of personal preference what you decide, considering they're all around the same range, only off by about 3%. So up to you which you would like to use. Okay, moving on into clustering. We're going to go ahead and analyze data using k-means and other clustering algorithms. And we also have to determine first the optimal k-value for these clusters. How many clusters do we want to use? And then we're going to try and attempt to assign profiles for these movies. Okay, so first and foremost, let's do a variance analysis. As you can see, pretty widespread data, so we will definitely have to normalize. Here we go. This is the equation for normalizing. You can see that now, instead of apples to oranges, we're hopefully comparing apples to apples. All right, let's determine the k-value we'd like to use. I'm going to use the elbow method. You can see here that it falls between 4 and 5 where you would picture the elbow. So for me, I'm going to go ahead and choose 4 as my number of clusters. So we will set k equal to 4 for our first method, which is the k-means. There it is, very nice. Adding that on. All right. You can see here, this is important for when you create your profiles because these are the averages for each of the columns within each of the clusters that we created, each of the 4. And so when I create my profiles, which I will go into here in a minute, I based my assumptions off of these average values and compared them against each cluster. So looking at the spread here, you can see that there's quite a few in cluster 3 and cluster 1, but at least it's not super all in one bucket or all in the other. You can kind of see a nice spread here in the visual. These are our 4 clusters. Very nice. All right, so now agglomerative clustering. Our second method, we're going to also use k equals 4. And this is just a quick visual of those 4 clusters. And you can't see super well at the bottom here, but these numbers down at the bottom are a little bit different than our first method, but for the most part, pretty similar sizing as far as how many movies go into each of the 4 clusters. So you can kind of choose which one you prefer. And then the profiles, this is what I came up with based off those averages that I mentioned. Profile 1, the longer movies with more popular actors based off their Facebook likes. They have the highest number of voted users, high number of user reviews, decently high budget, maybe not as profitable. So overall, a decent movie. Number 2, low number of critic reviews, not very many Facebook likes, lowest number of voting users, low budget, low scores. Overall, not super great movies, I would assume. Number 3, longer duration, highest number of critic reviews, decent amount of Facebook likes, high number of voting users, very high budget. So you would hope that these perform well. And cluster number 4, short movies, moderate likes, less user reviews, low scoring, and they're absolutely not profitable. So that is a bummer. Those are our 4 clusters. And real quickly, I'll try to summarize what just happened. In case you haven't kept up, we ran some regressions. The best one that we ran was by far Random Forest. We also came up with top 5 important features. You can see those there. And then it seems to me like a big factor is involving people and the ones who are forming opinions and then doing something about those opinions, whether they're voting or they're filling out reviews. They're pretty influential according to this analysis. And then we went into classification, created those bins, and the model that we selected was 67% accurate. It was able to accurately predict the movies. We used an additional feature selection technique, RFE, came up with almost the same important features aside from the number of faces in the posters. That one was strange, don't know what happened there. Tested out a bunch of different classification methods, and they all fell into the same range, didn't really see any huge differences or one that was significantly better. And then lastly, we did clustering, decided on 4 as our number of clusters that we'd like to use, and then developed profiles based off those 4 clusters. So one last additional variable that I would like to see in the future that may have helped with this analysis and kind of added some additional insight probably would have been the advertising and promotional efforts that went into these movies. And I feel like knowing that would have influenced how successful the movies were and probably gone into what the rating that they later received. So if I could change anything about this data set, it would probably be having that variable in the future. That being said, I think that is the summary of what all we've done. Thank you so much for watching.